Let's talk about something we've all been through, the fragile lab environment. You know the feeling. You spend hours, maybe even days, getting everything set up perfectly. And then, one wrong command and the whole thing just crumbles. It's a universal pain in the tech world. But what if there was a smarter way to handle all that chaos?
No, really, just take a second and think about it. Add it all up. How many precious hours of your life have you lost because some simple test went sideways and you had to just wipe the whole thing and start from square one? We've all felt that sinking feeling in our gut. It's not just frustrating, it completely kills your momentum.
So, how do we get out of this cycle? Well, we've got a clear roadmap for you in this explainer. First, we'll dive right into that shared frustration. Then, and this is key, we're going to redefine what we're actually trying to protect. From there, we'll get tactical, when to take a snapshot, a super simple 5-step logic you can use every single time, and finally, how to restore with intention.
Right. This is the classic scenario. You're in the zone, deep into a security test, or maybe you're trying out a new software build. You're tweaking some really complex configuration. You type one little command, you hit enter, and boom, nothing. The system is corrupted, your test is totally shot, and you can just see your entire afternoon getting sucked into this mind-numbing rebuild. That is the exact frustration we are talking about.
Okay, so when that happens, what's our first instinct? Damage control, right? Just keep the system alive. But what if that's the wrong goal? What if the thing we really need to protect is something way more subtle, and, in the end, a lot more valuable than just a green online light?
You know, the conventional wisdom in IT is all about uptime. Is the server online? Is the service responding to a ping? And look, in a production environment, that makes total sense. But in a test lab, a system that's running isn't always a useful system.
And here it is. This is the big aha moment of this whole thing. In fragile labs, the real thing you're protecting is not uptime. It is context. Seriously, once you let that sink in, it'll completely change how you approach your work.
So what on earth is context? Well, think of it as the entire backstory of your environment. It's the specific software versions, the exact configuration files, the whole sequence of commands that got you to this point. If you lose the context, your test results are basically meaningless, and there's no way you can repeat them.
So if context is king, then our tools have to serve the king. This is where we make a huge shift. We stop thinking about snapshots as just a reactive, undo button for when things go wrong, and we start using them as a proactive tool to preserve that precious context.
This gives us a really practical way to decide. A simple reboot? Yeah, that's fine if a process hangs or a service just needs a quick kick. But you should be reaching for that snapshot button before you do anything that fundamentally changes the lab's context, like installing new software or making some risky change to the configuration.
And this quote just nails it. A system can boot up just fine, but it can still be dirty. You might have leftover files or altered settings from a previous test that could totally mess up your new results. Always remember, a machine that's simply on is not the same as a machine with a clean, known context.
So to make this super easy, just use this mental checklist. Before your next big move, ask yourself these 3 things. 1. Is my lab stable right now, in a known good state? 2. Is what I'm about to do complex or kind of risky? And 3, would undoing this manually be a total nightmare? If you answer yes to even one of those, it's time to take a snapshot.
The big takeaway here is all about being proactive. You don't wait for the car to crash. You take a snapshot before you even enter that messy, confusing state, that moment you risk losing that clean, understandable context.
And that brings us to the heart of this whole thing. We've talked about the why, so now let's get down to the how. Here is a simple 5-step process you can use every single time to put this into practice. It's going to make your testing way more rigorous and a heck of a lot less frustrating.
Okay, let's walk through this. Step 1. Verify calm. Just make sure the system is idle, stable, nothing crazy is going on. Step 2. Take baseline. Create your snapshot and please give it a clear descriptive name. Your future self will thank you. Step 3. Note the boundary. Be specific. Write down exactly what you plan to do. Step 4. Test carefully. Execute only that one planned action. And finally, step 5. Restore intentionally. This is huge. It means you make a conscious choice to either keep the changes or roll back, and you know exactly why you're doing it.
Yeah, that last step, restoring with intention, is so important that we're giving it its own section. Because a rollback shouldn't just be about convenience. It has to be an act of learning.
And hey, if you ever doubt if this whole process is worth the effort, just do the math. A 5-minute restore versus a 4-hour rebuild from scratch. The time you save is enormous. That's time you can spend doing actual, productive work instead of rebuilding things.
To make that rollback truly educational, you have to treat it like you're writing a lab report. Before you hit restore, document everything on this checklist. What was the snapshot's name? What did you test? What did the logs or errors say? And most importantly, why are you rolling back? This is how you turn a failure into a valuable piece of data.
And this quote just ties it all together so perfectly. Good notes transform a rollback from being merely convenient to being truly educational. It's the absolute best way to make sure you don't make the same mistake twice.
So the question I'll leave you with is this. How will you start protecting your context, not just your uptime? I promise, once you start applying this mindset, it won't just save you countless hours of rework, it'll make your entire testing process smarter and so much more effective.